Hello. Our engineering firm, the League of Extraordinary Engineers, is in charge of designing the North Mendota Parkway. Our design team is comprised of Jamie Cozy, Elliot Morris, Ching Lee, and Andy Udick. Our proposed section is Route 4W, which connects US Highway 12 and Pheasant Branch Road. The construction site will be south of Fisher Road and mostly flat farmland, as shown in this picture. Based on the North Mendota Parkway Alignment Screening Report, a 4-lane parkway alignment is recommended. We wanted an urban parkway design supported by curb and gutter for drainage. Therefore, we chose a functional classification of an urban arterial with a corresponding design speed of 55 miles per hour. A grassy median will not only help for drainage purposes, but it will also aid with the forgiving roadside and clear zone concept. Considering the roadway's categorization as an urban arterial and parkway, we chose cross-sections with features typical to these classifications. For all cross-sections, 12-foot lanes, a 42-foot median, and 30-foot clear zone were used. Instead of having shoulders, we are specifying a curb and gutter. The medians and clear zones have a 6-to-1 slope, which is the smallest value commonly used in order to provide the safest outcome for vehicles leaving the roadway.
For areas with no superelevation, a normal crown of 2% is used, with this value increasing to 6.25% in the 2-foot wide gutters. When superelevation is necessary, 2 of our horizontal curves use a reverse crown superelevation of 2%, and 1 curve requires 3%. Our cross-section specified includes curbs. Due to relatively high speeds, a mountable curb is specified to avoid sudden decelerations and possible rollover accidents caused by the barrier of an unmountable curb. Because we are expecting vehicles to occasionally leave the roadway, the traditional value of 30-foot clear zone is specified. With the cross-section in place, a horizontal alignment could be designed. Our starting point for design was the 4W alignment provided by Strand Associates. However, this design had to be modified in order to tie into Pheasant Branch Road at a 90-degree angle. Our goal was to provide curves with large radii in order to reduce the rate of superelevation. We also wanted to provide long enough distances in between horizontal curves to meet sight distance requirements. Once the horizontal alignment had been decided, a vertical curvature must be designed. A contour map could be generated based on a downloaded USGS map. The existing roadway beneath our horizontal alignment varied in elevation by only around 40 feet, which is quite small compared to our overall length of 1.4 miles. Because of this, very small grades were specified, ranging from the minimum value of 0.5% through 1.5%. It was important in our design to make sure that our roadway approximately followed the existing topography, but without having an excessive number of vertical curves. Care was given not to place horizontal curves immediately following vertical curves due to limited sight distance, as well as other human factors issues that are important to consider when combining vertical and horizontal curves.
By plotting the existing elevation with the stationing from our horizontal curve, an idea of the proposed grades for our road could be obtained. You can see by this plot that in order to reduce the amount of material that needs to be cut or filled, our road would have to travel downhill in this section, then go back uphill in this section, all the way up to the high point, and then go back downhill to reach our final elevation of about 957 feet, which is where we tie into Pheasant Branch Road. So if you look at our proposed vertical alignment, you can see in some spots, maybe about here, we'd have to put a lot of fill material in order to get the road up to this level. And then around over here, we'd have to cut the material to get down for the proposed elevation of right here.
Once the vertical profile was created, a drainage calculation could be made to determine peak runoff rate in cubic feet per second, the number of inlets needed, and the spacing of those inlets. For the runoff rate Q, to use equation Q equals QRA, firstly we need to determine C, I, and A. There are 3 straight segments and 3 curves. Given length of the segment and the width of travel lanes, we can calculate drainage area. Then, according to FDR, by using height of most remote points and length of segments, time of concentration could be determined. Intensity of rainfall is calculated by using time of concentration from the diagram in FDR. Since concrete pavement is assumed, runoff is given from the table in FDR.
our group was really fascinated by the Neenah Foundry product catalog, so we spent a lot of time searching through all of it and picking the perfect inlets for our road. So eventually we chose inlet type A. We chose the R3010 product. After doing the calculations, we found that the inlets can capture 100% of runoff, therefore we can place them at the minimum spacing, which is 600 feet, while always placing them at the low point of sag vertical curves. So here you can see we plotted our horizontal curvature on the contour map, and you can see our high point is right here at station 4453. So first, if we work from the high point downward this way, if we go from the high point to curve B over here, we have a total of 4 inlets placed every 550 feet, shown in the figure. And then from the low point, which is right here of this curve, which is station 2312, there's another 4 inlets to the beginning of our alignment, spaced every 485 feet. And then if we go back to the high point and work our way this way, there's a total of 4 inlets spaced every 385 feet, and this is a constant slope for the road all the way to the end until our low point here at 7380. So total, that's 13 inlets on each side of the road, and then they're on both sides, and then there's 2 directions, so in all we have 52 inlets total needed. So as stated before, our design roadway has 1 interchange at 1 at-grade intersection. Our proposed parkway intersects with Pheasant Branch Road, a 2-lane street with relatively small traffic flow rates. Under the assumption that our design parkway will be ending at this road, a 3-leg at-grade intersection was designed. The design vehicle of the parkway is a WB62 interstate semi-trailer. Due to this vehicle's wide turning radius, 2 corners were created using a 3-radius design, which is more efficient use of paving materials than the constant radius corners. A semi-actuated signal will be used, activating a green light for the Pheasant Branch Road only when traffic is detected, and giving the green light to North Mendota Parkway the rest of the time. Finally, we ensured that horizontal and stopping sight distances were met, given that this intersection occurs fairly shortly after a vertical and horizontal curve.
For the interchange with the existing beltline, a trumpet-style interchange will be used. Note that the left turning movements on the schematic are not shown. Tapered ramps with a design speed of 45 miles per hour will be used to merge on and off the new parkway. A trumpet intersection was deemed to be the most efficient way to accommodate relatively high flow rates, considering that this will be a busy 3-legged interchange. The configuration is also economically feasible in cost for bridge structures. Another major factor that influenced our roadway design was safety. Using the WISTrans portal, we were able to analyze crash data for the project area. Because our project designs a new roadway, current crash and traffic data was not available for the exact route. However, we were able to look at crash data on US 12 and Pheasant Branch Road between County Line K and Fisher Road to gain a better idea of the area. From 2009 to 2013, there were a total of 13 crashes on US 12 and a total of 15 crashes on Pheasant Branch Road. None of these crashes were fatal. When focusing on the crash location, we did notice that there was a pattern for crashes at intersections. Specifically, the intersection of Highway K and US 12 had 38 crashes between 2009 and 2014. The intersection of Pheasant Branch Road and Highway K had 12 crashes between 2009 and 2014. Using this information, we focused on introducing various techniques to increase the safety of our intersection. For example, in order to regulate traffic flow, we included a signal with semi-actuated detectors, with Pheasant Branch Road as the minor road. Additionally, the median provides a barrier for further protection from the turning lanes. The large turning radius also allows vehicles the room to turn safely. With this being said, that concludes our presentation of the main design concepts of this project. Thank you for listening, and for further information, please refer to the DSR and design sheets. Thank you.